Alright, let's hit up some vocab. Now, we've been talking about these quadratic functions and these U-shaped things right here. This is a quadratic equation right here. Now, these U-shaped things, they're called parabolas. They're given a very special name. They're called parabolas. Now, the function has three terms. Let's take a look at this part right here. I know I keep scrolling up and down. I apologize. This one technically only has two terms, but it could have three terms. Like, for example, this has three terms. A quadratic equation will have up to three terms. It could have one term or two terms, but it will have up to three terms. Now, those three terms are most generally expressed as ax squared plus bx plus c. This is called the quadratic term. This one is called the linear term, and this one is called the constant. Similarly to y equals mx plus b, the x's are the variables, whereas a, b, and c, in this case right here, a, b, and c, are coefficients. A, b, and c are called coefficients. They are just straight up numbers. Now, just like how m describes the angle that the slope is at and the b describes the intercept that this slope is at, the a, b, and c are going to describe different ways that this parabola can go. The a, I'll give you a hint, will kind of describe the fatness of the parabola, where if it's a skinny parabola or a fat parabola. It will also tell you whether or not this thing goes upside down. The c tells me about the y-intercept. It usually tells me something close to like where the thing crosses the y-axis. The b, on the other hand, that one will do something funky, and I can't tell you exactly what it does. To be honest with you, I think that it basically moves things right and left, but not exactly. It doesn't move it perfectly right and left. There's a technique that we're going to be looking at later on, but basically just know that these a, b, and c are just straight up coefficients. They are numbers, and that's it. And that they alter the shape of the parabola that we're talking about. Please don't get this b over here confused with that b over there. They are different b's. Which parameter can't be 0? Okay, in this case up here, we don't have a middle term. There is no term with an x, because it's ax squared plus bx plus c. In this case, b is actually 0. The number b is 0. Because we have a number in front of the x squared term. Actually, you don't see that number, but it's a number 1. We have a number that's actually for the c, which is -4, but there is no b. So what I'm saying here is, which one of these numbers, a, b, or c, cannot be 0? B can be 0. We just saw an example of that. C can also be a 0. That would mean that this intercept crosses right at y equals 0. However, a cannot be 0, and it's a very simple reason. If a were 0, then what would happen is your f of x would equal, I'm going to use this thing right here, 0 times x squared plus bx plus c. Alright, if 0 times x squared, that's just simply 0. So really what I have is bx plus c. Now wait a second, bx plus c, that looks a lot like y equals mx plus b. Of course I changed up some of the letters or whatever, but this is an equation of a line. So simply saying, if a were 0 in this particular case, then this thing is no longer a parabola, this is a linear function. That's why a can't be equal to 0. It's not because something's being divided by 0 or something's outside of the domain or range or whatever. It's simply that if a were equal to 0 in the ax squared plus bx plus c, then you're dealing with a straight up line. Alright, let's do this page and then I'm out. Now, which one of these is a quadratic function? Is this a quadratic function? Yes, it has x squared, it's got a 6x, it's got a 9. Is this a quadratic function? Number 2. In this case, even though you see an x squared, it's not a quadratic function, because this is actually a linear function. In fact, I could graph that for you. It would be a slope of -1 and an intercept of 12. So I go 12 and I go down like that. That's -1. Boom. That's the graph of that. This is a linear function. This is a linear function. This is not. I mean, I'm sorry. I'm sorry. I apologize. This is a quadratic. This is a quadratic. This is actually. Did they say that's linear? Yeah. This is not quadratic. We in fact discussed what this is. This would be a graph that has a slope of 0 but a intercept of 6. We're talking about a horizontal line over at 6. So that's not a quadratic function. I know I skipped that one. I'll let you do it. I'll let you do this one and figure that one out. Alright, have fun.